Welcome to Ask and Learn.
Okay, so this problem relies on information from the previous two. So in problem 41, we are given that we want k to be the smallest integer such that n is less than or equal to k times k plus 1 over 2. Okay, and in problem 42, we're introduced to the telescoping nature of this formula, right? So that r of n minus r of n minus 1 is equal to 2 to the power of k minus 1. So we're going to use both of these here. And so first we'll consider, that r of n is equal to the sum, let's let j equal 1 to n of rj minus r of j minus 1. So this is from the telescoping nature of the sum here in problem 42. And the fact that r of 0 is equal to 0, okay, which was also in, I think, problem 41. Okay, well, so this is the sum for 2 to the power of k minus 1. Okay, but the thing is, k, being a integer, is going to be constant for some successive values of j, right? And so let's consider it for I successive values of j. K is going to be the same because it's forced to be an integer. And so then this sum is going to become the sum to k, where I is equal to 1, of I times 2 to the power of I minus 1. Now, the problem is that if n is not a triangular number, then the last few values, where I is equal to k, would be missing. So we need to add those on. Okay. And so to add those numbers in, okay, we add this last little term here, right? So we get the sum from I is equal to 1 to k of I times 2 to the power of I minus 1 minus, okay, then we get the triangular numbers, minus n, 2 to the power of k minus 1. So this just adds on those last few numbers of the sum that would be missing here, and that gives us our expression.